Hi friends, welcome back. Today we're going to talk about solving quadratics by completing the square. If you're in the Lawson book, it is 10.5, I believe. I'll double check that when I post it. First things first, your notes. A perfect square trinomial. Okay, so we'll get rid of all these guys here. All right, so perfect square trinomials are a binomial that is to the second power. So like right here, I have 2x minus 3 squared, quantity 2x minus 3 squared. What's neat about these is you could write them out 2x minus 3 times 2x minus 3 and then FOIL them all out, but they actually have a pattern. And that pattern looks like this. You take the first thing and you square it, so 4x squared. You use this first sign, minus, multiply these two things together. 2x times 3 gives us 6x. Double it, you get 12x. And then this is always positive at the end. And then 3 squared is going to be 9. So this is a perfect square trinomial. Now we're going to be using that information. I think you learned it in the previous unit. We're going to be using that information to complete the square so that we can create a perfect square trinomial. What that means is you basically just take half of this guy and square it. So what I like to say is, okay, we're going to do half of 14 squared. 14 squared is 196. So I would need to put 196 here, and that would turn it into a perfect square trinomial. And that perfect square trinomial would be P plus 14 squared. Okay, let's look at this one. Half of this guy is negative 7. So, oops, I didn't mean to put it right there. Sorry about that. Negative 7 squared. Now remember, quantity negative 7 squared is negative 7 times negative 7, which is positive 49. So if I had x squared minus 14x plus 49, I would have a perfect square trinomial. And that trinomial would look like this. X minus 7 squared. Now these have been easy because they're even numbers. Sometimes you get an odd one, which is kind of annoying. However, when we get odd ones, you don't want to do a decimal. What you want to do is half of 11. If you're not sure what half of 11 is, you take 11 and you multiply it by 1/2. Remember, we multiply straight across the top, straight across the bottom, so I can turn 11 into a fraction. So I get 11 halves. So half of 11 is 11 halves, and we square it. Don't forget the negative because there's a negative here. And that is important. It doesn't change anything when we're squaring it here. And again, I put it in the wrong spot, I'm sorry. It doesn't change anything when we're squaring it here, but it does change it. We are turning it into a perfect square trinomial, which is x minus 11 halves squared. Now, what would go in this box is, and I should have moved this, I'll move this down here, negative 11 over 2 squared. And then what goes in this box up here is 121 over 4, because 11 squared is 121 and 2 squared is 4. All right, same thing over here, 5 over 4, we need half of that. Do a little bit of side work. Off to the side, we can say, all right, let me see if I can find a marker. Off to the side, we're like, all right, half of 4/5 times 1/2, well, that's going to give us 5 over 8. All right, cool. So now we know that half of negative 5 over 4 is 5 over 8. So this time I won't write it in the wrong spot. We get negative 5 over 8 squared. Well, up here, that's going to give us 25 over 64. Because negative 5 times negative 5 is 25, and 8 times 8 is 64. Now, if we were to turn that into a perfect square trinomial, it would be P minus 5 over 8 squared, or if we were to factor that perfect square trinomial. Okay, so now we're going to use perfect square trinomials to actually solve quadratic equations. We're going to start with this first one here. The way that you do this is you want to get all your x's on one side, all your non-x's on the other. So I'm going to minus 33 from both sides. Now, when I go to rewrite this, I'm going to leave a spot. So I have x squared minus 14x. I'm going to leave a bit of the room equals negative 33. In that space, I'm going to do plus my bubbles squared, which is what I was doing back up here. But of course, if I do it to one side, you got to do it to the other. So plus bubbles squared here. Now, I take half of this, which is negative 7, negative 7. So now this is a perfect square trinomial, and I don't need to write 49 out to know that it's perfect square. All I have to do is take one of these. So x minus 7 squared. So I've just factored this thing here into x minus 7 times x minus 7, or x minus 7 squared, equals, a little bit of side work here, quantity negative 7 squared is 49. Okay, and if we have 49 minus 33, we've got 16. So positive 49 and negative 33 gives us positive 16. All right, now we're ready to solve this equation. So two things. One, if you wanted to turn it into vertex form, you could very easily here, just minus 16 from both sides. You would have x minus 7 squared minus 16 equals y, or f of x. That's your vertex form, right? But in this case, we are solving, but I just wanted to point that out. So in solving, now that we've isolated our squared, we're going to do the opposite, which is square root. So we're going to square root both sides. A little bit of side work to remind you. 3 squared is 9, and the square root of 9 is 3. So you see how those cancel each other out. So this cancels this, and I'm left with x minus 7 equals. Now, when we're taking something out of the radical, you have to do plus minus. So plus minus the square root of 16, which we know is 4. Now, this seems kind of silly. You have two equations here, but this seems kind of silly, but I want you to add 7 to both sides before you separate your equations, because when we get to irrational solutions, it makes a little bit more sense. So plus 7 plus 7. And so the way we write that is x equals 7, and it's positive, right? Plus minus 4. So if you need to, you can write these out as two separate equations where we have x equals 7 plus 4 and x equals 7 minus 4. And if we do that, we get 11 and 3. So x equals 11, x equals 3. We have two answers. How many answers should we have? 2, because you always want to look at your highest exponent and see. That'll make more sense in algebra 2. It's not always a guarantee either. Sometimes you'll have one or no solution. But it's a good idea to ask yourself, how many solutions do I have? How many should I have? If you don't have 2 solutions, you should know why. Okay, so let's talk about this next one. All right, let's practice completing the square on this guy. So straight away I look at that, I see all of them are divisible by 2. And so I'm going to divide every chunk by 2 because that'll make my life a lot easier. So x squared plus 10x minus 4 equals 0. Now to complete the square, what we have to do is get them the variables on one side, non-variables on the other. So I'm going to add 4 to both sides. So I end up with x squared plus 10x, and I'm going to leave a space, equals positive 4. Now I'm going to add bubble squared to both sides, because if I do it to one, I have to do it to the other. And a lot of mistakes I see are you forget to put your plus sign. So look down, make sure that you put a plus sign there, not a multiplication. I'm going to take half of this middle term here, which is 5. The term is 10, half of it is 5. And now I have x plus 5 squared, because now I've turned this into a perfect square trinomial, equals 5 squared is 25. So I have 4 plus 25, which gives me 29. Okay. So now we're ready. We've isolated our squared. So now we're ready to solve by using the by square rooting both sides using the square root method. So we have x plus 5 equals plus minus, because we're taking it out of the radical. Now 29 can't really, there's no perfect square hidden in there. You can't simplify it. It's not a perfect square. So we're going to leave it as root 29. If you minus 5 from both sides, you now have, I'm going to write it over here, x equals, and you always want the plus minus to be in the middle. So we're going to say negative 5 plus minus the square root of 29. Now you can solve these as decimals. We could go in and say, okay, the square root of 29 is 5.39. So what we could say is, I don't want to run into the, well, that's right. We could say x equals negative 5 plus minus 5.39, which means we have x equals, so this is the most accurate answer right here. But if your teacher asks for decimals, you can separate this out. Negative 5 plus 5.39, x equals negative 5 minus 5.39. Add the opposite here, x equals negative 10.39. And over here, we would get x equals positive 0.39, or 39 hundredths, and negative 10, 39 hundredths. But I think this is the most accurate way to leave your answer. But if you need to do decimals, you absolutely can. All right, let's look at number 3. This one's a little bit trickier. So we've got, it's already variables on one side, non-variables on the other, but what I need to do is leave a space. So I'm going to say w squared minus 5w plus bubble squared equals 11 over 4 plus bubbles squared. Okay, now I need half of 5, and negative 5, right? I don't want to do a decimal, so what I'm going to do is say negative 5, put it over 1 times 1/2. Multiply straight across the top, straight across the bottom, I get negative 5 halves. Negative 5 halves. Negative 5 halves. Okay, this is now a perfect square trinomial. It is w minus 5 halves squared equals. This is a little bit of side work. You're going to want to do this over here. 11 over 4 plus. Now, quantity negative 25 or negative 5 over 2 is going to be 25 over 4, which gives us 11 plus 25 will give us 36. So we come back over here and we take that information over here. We get 36 over 4. All right, now we're ready to use square roots. Square root both sides, we get w minus 5 over 2 equals, and we're going to be taking something out of the radical, so plus minus. And remember, if these are under the same roof, I'm squeaking there, you can separate them out. So 36 root 4, which would give us 6 over 2. So 6 over 2. I know that reduces down to 3, but we're going to keep it as a fraction because we're going to add 5 halves to both sides. That will get that w by itself. So now we have w equals, and you want to put the plus minus in the middle, so we're going to start with this one, 5 halves plus minus 6 halves. So we have w equals 5 plus 6 over 2, and we have w equals 5 minus 6 over 2. So in this case, we get 11 halves, and in this case, we get negative 1 half. So our answers are 11 halves and negative 1 halves. We have 2 answers. How many should we have? 2. Perfect. That is how you complete the square in Algebra 1. If you have any questions or if I made any mistakes, let me know below. Otherwise, good work, and we'll see you next time.